Hi, welcome to the 8.1 video. In this video we're going to be talking about operations of functions. So we're going to start us off with adding functions. So we see here that we have one function called f of x and we have another function called g of x. Now remember, this is just a way to get us to talk about functions with different names. This really means like y equals, but to be able to to talk about the different functions, we can call one of them f and one of them g. When we want to add functions together, we might see something like f plus g of x, or that means the same thing as f of x plus g of x. If I wanted to write just a general function for that, I would take my f of x plus g of x. I know that f of x is this 4x minus 1, and that g of x is the x plus 5. So if I write that in, I'm going to replace f of x with 4x minus 1. I'll replace g of x with x plus 5. And I can combine some like terms. All right, so 4x plus x gives me 5x, and negative 1 plus 5 gives me 4. If I wanted to plug something in and deal with f of 3 plus g of 3, remember, that just means wherever you see x, replace it with 3. Now I know that f of x plus g of x is equal to 5x plus 4, so I could plug in 3 for x, and I end up with 15 plus 4, or 19. Okay. In addition to adding functions, I can also find the difference of functions, also known as subtracting. The way this looks is f minus g of x, or f of x minus g of x. So if I want to take f of x minus g of x, I can plug in, same stuff again, g of x I'll make yellow, f of x I'll make green. So if I have g of x, that's 4x minus 1, okay, and I'm going to subtract. Okay, well, when I'm subtracting, I'm going to probably throw this into some parentheses here to remind me that I'm subtracting the whole quantity. All right, so I'm going to subtract g of x, or x plus 5. All right, so now I'm going to combine some like terms. So if I'm going to deal with 4x minus x, that gives me 3x, and negative 1 minus 5 gives me a negative 6. If I wanted to find f of, I'm missing a 7 here, minus g of 7, I could plug into those individual functions, or I can plug into that combination. So I can type in to my calculator, or figure out in my brain, 3 times 7 minus 6, or 21 minus 6, which gives me 15. We can keep going. Product of functions. Remember, product means multiplication. All right, we can write it f times g of x, or f of x times g of x. All right. So if I'm going to multiply those together, I'm going to start with 4x minus 1 in one set of parentheses times x plus 5 in my second set of parentheses. I'm taking a binomial times binomial, so that reminds me that I need to FOIL. First terms, 4x times x gives me 4x squared. 4x times 5 gives me 20x. Negative 1 times x gives me negative 1x. And last terms, I have a negative 5. Combine some like terms, and I have 4x squared plus 19x minus 5. All right. We can also take a look at quotient of functions, and remember, quotient means division. All right, so we're going to do this in two different ways. We're going to talk about f divided by g of x, or f of x divided by g of x. Okay, so when I plug that stuff in, I'm going to deal with f of x being this x minus 3, and I'll deal with g of x being x minus 5. All right, so division. Our whole last unit, we were talking about division and rational numbers, and we were really focused in on making sure that the bottom, or the denominator, is not 0. All right, so if we're going to plug this stuff in, f of x is going to be hanging up at the top, so square root of x minus 1. Sorry, square root of x minus 3. And on the bottom, we're going to be dealing with x minus 5. Okay? So hanging out over here, it's asking us for our domain. All right, so let's focus on what we've been looking at before. So in the bottom, or in the denominator, we see that we're hanging out with x minus 5. We know that our denominator can't be 0. Okay, so we know that x cannot be equal to 5, because 5 minus 5 gives us 0. Okay, domain also deals with any number that we can plug in. Well, hanging out up at the top, I see the square root of x minus 3. Now remember, the square root, we can't take a square root of a negative number and end up with a real number. So in this case, x would have to be, well, 3 minus 3 gives me 0. I can take the square root of 0. And I can take the square root of larger numbers. So x would have to be greater than or equal to 3, but it could not be 5. Okay. Conversely, if we came across a problem where it was talking about, all right, let's flip this upside down, g over f of x, also known as g of x over f of x. All right, so let's just flip this thing upside down. All right, so we have x minus 5 hanging out up top, and on the bottom, we have our square root of x minus 3. So if we focus in on the bottom stuff, on the bottom, okay, we know we can't divide by 0. So we can't use a number that's exactly equal to 3 anymore, but we can use larger numbers. So x can be greater than 3. Okay, up at the top, we don't care if the top is equal to 0, so this is all we get for our domain. Okay, so this is in terms of a function if we're dealing with an actual function in terms of f of x or g of x. We can also deal with functions where we are given just coordinates. All right, so let's take a look here. If I want to find, notice in this top line, we got our f junk happening, and in the bottom line, we have our g junk happening. So we're looking for f of x plus, or f of 2 plus g of 2. So if I'm starting out with the f stuff, okay, f of 2, and I'm plugging in 2, if I take a look and examine, all right, here's my x coordinate of 2, and what pops out is 4. So f of 2 gives me 4. Okay, in the same way, I'm going to take a look at my g of 2 stuff. Okay, so g of 2, I'm looking at the function that's hanging out in yellow. Okay, I'm going to look through and find the x coordinate, that's 2, and what pops out is 7. Okay, so f of 2 plus g of 2 is going to give me 11. All right, so that's how we can deal with this in terms of coordinates. All right, we have one more topic to take a look at, and that's our composition of functions. All right, so composition of function is writing one function in terms of another. Okay, and when we deal with our composition of functions, we're going to use this little open circle symbol. Okay, it kind of looks like it says fog. So notice here, we got this open circle deal, meaning that we are going to be dealing with our composition. Okay, not to be confused with our dot for multiplication. Okay, so that's one way you could write it. You could also write it as f of g of x. All right, so if I wanted to evaluate f of g of x, in this type of problem, we always work from the inside out. So the inside is g of x. And so I know that g of x is equal to x plus 5. So I'm going to plug in, instead of writing g of x, I'm going to write in x plus 5. Now this time through, I'm looking to evaluate f of x plus 5. So I'm tying it back to this f function. Now we know that originally this was in terms of x, but now wherever we see x, we're going to plug in x plus 5. So we have going on, we know that we have the 4, but instead of x, we're going to write down x plus 5. And I know in that composition of function, that function f subtracts 1 at the end. From here, I'm going to distribute. So I have 4x plus 20 minus 1, and that's going to turn into 4x plus 19. Okay. We can also do this in a different way, and I want to show you that if we reverse the order, most likely we're getting a different result. So if we want to find g of f of x, the order is going to change. So g of f of x, I'm going to start out with grabbing the f stuff. Okay, and remember the f stuff is 4x minus 1. So instead of writing down f of x, I'm going to write down 4x minus 1. Okay, so now I'm looking at function g. And g, I know, ties back to g of x equals x plus 5. But instead of writing down x, I'm going to write down 4x minus 1. So, replacing it, hanging out front, I have a 4. But instead of writing x, I'm going to write down, let's back it up here. Okay. Instead of writing x, I'm going to write this whole expression, 4x minus 1. Okay, so that's instead of plain old x, I'm writing 4x minus 1 because that is my new x. Okay, and at the end, I'm adding 5. Combine some like terms, and we have 4x plus 4. All right, so that's the end here. Make sure you take some notes and write it down, and we'll check base again next time I see you. Bye.